There's a big idea in cosmology these days, one that could change the way we understand the universe. Dark matter, that mysterious substance that seems to bind the universe together, could be made of, wait for it, mini black holes. I know, what does that even mean? And why are scientists getting really excited about this now? First, let's back up and talk about what we know about dark matter. The answer is not much. In the 1920s and 30s, physicists noticed something funny about how stars and galaxies were moving through space. For example, in 1933, Fritz Zwicky observed that galaxies in the Coma cluster were moving too fast to be gravitationally held together by the mass in the neighborhood. He reasoned that something must be missing that was keeping them from flying apart. But it wasn't until the 1970s that Vera Rubin and collaborators confirmed this by showing that the speed of stars moving around spiral galaxies could not be explained without a massive amount of invisible matter. And so for half a century, physicists like me have been trying to figure out what is this invisible or dark matter. For decades, we thought that it must be some new kind of subatomic particle. The clear leading contender was weakly interacting massive particles, or WIMPs for short. We've built all kinds of detectors to try to find WIMPs, from large arrays of sensors embedded deep in the Antarctic ice, to a multi-ton chamber of liquid xenon. Even the Large Hadron Collider has been used to try to detect dark matter particles. But WIMPs aren't the only candidate particle. There's also gravitinos, axions, Kaluza-Klein particles, WIMPzillas. Still, despite decades of hard work and clever experiments, we haven't found any of them yet. For a while, it felt like a dark matter dark age, when experiment after ever larger experiment came up empty. And that's when an overlooked theory started getting some traction. Black holes. Black holes are places in space where matter is so dense that nothing, not even light, can escape the gravitational pull. So they're dark. Check. But the black holes that we are most familiar with are what scientists call astrophysical black holes. These are really massive, even more massive than our sun. We found these by studying the effects on stars around them, detecting the gravitational waves they produce, and even taking a picture of the hot stuff orbiting them. But here's the problem. We know that dark matter can't be black holes of this size, because we would have found a lot more of them by now. But black holes could also be small. Really small. They're called primordial black holes, or PBHs, because instead of forming from the collapse of stars, they would have formed in the first tiny fraction of a second after the Big Bang. This is a time before atoms even existed, when quantum fluctuations could have created little pockets dense enough to trigger gravitational collapse. And this could have led to the formation of black holes that are much smaller than the ones we've detected so far. Think like the mass of an asteroid, but packed into the volume of a single atom. And these would be floating around our universe, maybe even our own solar system. There could be enough of these PBHs lurking around to make up all of the dark matter. And they would be tiny enough to be hard to spot, which would explain why we haven't confirmed them yet. But here's the really exciting thing. If dark matter is made of these primordial black holes, we should be able to find them soon. Existing experiments are just getting sensitive enough, and new ones are in the works. For example, by looking at the Moon or Mars, whose positions we know super well, we could detect small wobbles to their orbit caused by a passing PBH. Or we might be able to detect black hole radiation from an exploding PBH. In fact, it's possible we already detected this. All this means, after decades in the dark, we might be on the cusp of making a major breakthrough. Now, what do you think would happen if a PBH hit Earth? Let me know in the comments. I feel way too awkward about this. Maybe it's because I love dark matter.